Assalamu alaikum wa rahmatullahi wa barakatuh. This is the second video of Chapter 11, Part 1, Work and Power. At the end of this video, you're going to be able to calculate the work done by the constant force weight. Let's remember first what we took in the last video. We said that the work done by a constant force is the amount of energy taken or given to a system, then results in displacement under the action of a force. The work done by a force between A and B is given as the magnitude of F, the magnitude of AB, cosine alpha, which is the angle between F and AB. The work done by the force is an algebraic quantity. It may be positive, negative, or null, depending on the value of the angle alpha. We're going to start with solving an application about the video that we have taken in the last time. Consider a car that is moving from a point A to a point B along a horizontal road such that AB is 10 meters. During motion, the car is under the action of a motive force, F, which is 8,000 newtons, and the friction force, small f factor, of magnitude 1,000 newton. The first question. Determine the work done by each force exerted on the car during its motion. We represented the forces acting on the car on the figure. You just want to find the work done by each force. Pause the video and take your time to solve this part. Let's start. The work done by the normal reaction and weight mg is 0. Why? Because n and mg are perpendicular to the displacement. The work done by friction is FAB cosine the angle alpha. The angle alpha here is pi, since vector AB is directed to the left while the friction force is opposite to the tendency of motion and it is to the right. So the angle between F and AB is pi. Now the answer is minus FAB, where F is 1000 and AB is 10. The answer is minus 10 exponent 4 joules. Note that the expression of the work done by friction force can be directly written as minus F times AB. The same for the work done by the motive force F, which is FAB cosine 0, because F is in the same direction of AB, so the angle is 0. The expression FAB can be used all the time for the work done by the motive force, which is parallel to the displacement and with the same direction. Now the answer here is 8 times 10 exponent 4 joules. The second part did use the network of the external forces acting on this car. So we should add the work done by all forces. We know that the work done by N and mg is 0. So the answer is just adding minus 10 exponent 4 with 8 times 10 exponent 4. Finally, the answer is 7 times 10 exponent 4 joules. We can say here that it is positive, so the work done by all forces on the car is motive, and the car will move with the direction of AB. The work done by the constant force, weight. We have mentioned in the first video that weight is a constant force since its magnitude is constant, mg, and its direction is directed all the time vertically downward. But weight exists all the time in all our exercises. Therefore, we are going to make a special study for this force. Consider an object moving along a curvilinear path. The center of gravity of this object moves from point A of height A, which is the initial height, towards point B, HB, which is the final height. The work done by the weight of the object between A and B is mg vector dot AB vector. But we said before now that the work done by a constant force is independent of the path followed. Let's choose a position D in order to simplify our study, such that D is placed in a way AD plus DB equals to AB as shown in the figure. Now we can use the distributive property of dot product in our study. The work done by the constant force is mg dot AD plus mg dot dB. Then it is mgAD cosine 0, since the angle between mg, which is directed downward, with AD, which is directed downward, is 0, plus mgdB cosine 90, since mg is downward and dB is horizontal, the angle between them is pi over 2, and cosine 90 is 0, then the work done by mg is mg times AD. What is AD? From the figure we can find that AD is the difference between HA minus HB. So we always have the work done by mg between 2 points A and B on any trajectory is mg into H initial minus H final. It is good now to discuss the different directions of the object during its displacement and the different natures of weight. In the ascending path, where the object moves up, H initial is less than H final. Then the work done here is negative. Thus, the weight in this case is resistive force. In a descending displacement, where the object moves down a path, H initial is greater than H final, then the work done here is positive. Thus, we say the force of weight here is motive. In the horizontal displacement, H initial and H final are equal to each other, then the work done here is 0, and we say there is no work done on the object by the force of weight. Finally, if it changes its height but returns back to the initial horizontal level, like when you throw a ball upward and it returns back to your hand to the same initial launching level, we say that H initial and H final are equal to each other. The work done here is 0 and no work is done on the object. Let's solve this application. A box of mass m equals to 5 kilograms is pulled by a rope from the bottom of an inclined plane, making an angle alpha equals to 30 degrees with a horizontal. The box moves from a point A to point B. The magnitude of tension force exerted by the rope is 40 newtons, and the friction force has a constant magnitude 10 newtons. The first question: determine the work done by each force acting on the box as it is displaced a distance AB equals to meters along the inclined plane, and use G equals to 10 meters per second squared. Pause the video and think of the answer. The work done by the normal reaction of support is 0, since N here is perpendicular to the displacement. The work done by friction is minus FAB. As we said before, we can use it directly, so it's minus 10 times 2 equals to minus 20 joules. The work done by tension force can be written directly as T times AB, since T is a motive force and parallel to the displacement. Then the answer is 80 joules. We still have one force, which is weight. The work done by mg is mg H initial minus H final, but H initial is 0. What about H final? From the triangle showed in the figure, H final can be written as AB sine 30, since sine 30 equals to the opposite over the hypotenuse, and the opposite here is H final, the hypotenuse is AB. So solving the work done by weight becomes minus 50 joules. It's clear that the weight in ascending path is resistive force, since the work done by weight here is negative. It is enough for today. Remember all these ideas from the first video and add for it the work done by weight along any displacement is given as mg H initial minus H final. This is the end of part 2. Thank you for watching.